Okay, well, hi everyone. My name's Alice, and I'm going to be your lecturer for today's lecture on HSC Maths Advanced. So I'd like to say welcome to everybody who's here and everyone who's watching the recording. I'm super happy to have all of you here with us today. So for those of you who don't know, today's lecture is run by HR Notes, who are a company helping all students in Australia to have success in their final exams through Year 11 and Year 12. So in New South Wales, HR Notes is about helping prelim and HSC students make the most out of their Year 12 experience and just help them to achieve success for whatever your goal is in terms of specific marks for subjects. Maybe you've got a goal ATAR, so all those sorts of things. So if any of you guys want to check out any of the other stuff that HR Notes does, there's a link you'll see in the bottom left-hand corner, just here. If any of you guys want to take a look, feel free to use that link to do so. So some other stuff HR Notes does with some of the free resources that they do. So there's study notes, which are downloadable on the website, that cover all syllabus points for your subjects. Some of them also include some text guides for different HSC English Advanced and Standard texts that you guys might be looking at. So you can download those. There's also obviously these lectures, which you guys are all watching now, that they run for all the different HSC subjects, as well as some general ones on like doing well in HSC, ATARs. If any of you guys are interested in medicine, there's one at the UCAT. Just some free lectures from past students who know what sitting that exam is like and know what you need to do to achieve whatever goal mark you have in mind. So there's also some discussions that are like online Q&A forums between moderators from HR Notes as well as other students to help you get like a more broad perspective on, I guess, whatever subject you're doing, question types, potential essay questions, all sorts of things like that. And just like an insight into how the HSC actually works and stuff like that. So then there's also some videos, which are just like another way to engage with your syllabus content, and just like an engaging way to do some revision online. And then you've got the newsletter, which is just about staying up to date with the news about the HSC. Then you've got the ATAR calculator for every Year 12 student who inevitably gets to that point where you just need to look at, I guess, what marks you need to be getting to hit your goal ATAR. I guess every Year 12 student gets to that point where you're really putting things into that calculator to see how you can go. So if you want to look, or if you want to sort of take a guess at what ATAR you might be heading towards now, based on what sort of marks you think you might be getting, and just seeing if you're on track, you can check out the ATAR calculator. There's some articles just about different study strategies, tips, insights, and heaps of other free resources on the ATAR Notes website. So again, same link if you guys want to check that out. Just in the bottom left-hand corner. And then some other resources. There's TutorSmart, which is the ATAR Notes online tutoring, which comes from recent Year 12 grads who have done really well in the subject that you're looking to be tutored for, who can help you with like an inside knowledge about what it's like to sit that exam, what you need to be doing, sort of what revision you want to be doing to help you ace that exam. So there's some formal study guides that are printed revision materials to help you get great marks. Some of you guys may have seen those little books before. So they cover some notes, so like syllabus points, structured notes for a lot of your subjects. They have, again, the text guides that cover all the Year 12 and some of the Year 11 English texts, if you guys want to have a bit more of a look at that, to help you get like another perspective on, I guess, analysing your text. As well as they have some topic test books as well for some of the HSC subjects. So you can do some revision questions that are structured by topic to help you do some more specific revision while still doing application sort of questions. And then we've got Ed Unlimited, which is a place, like an online library, where all of those study guides exist in the one place, where you can look at all different text guides, notes for like every single different subject that has been published by HR Notes. So again, same link if any of you guys want to look at it. Just in the bottom left hand corner is hrnotes.com/register. Okay, anyway, so today's lecture is on HSC Maths Advanced. Yeah, I guess that's all I can say about that. I really enjoyed HSC Maths, and I hope all of you guys enjoy it too. It's one of those subjects that I guess if you do enough revision about, and if you look at enough question types, you can be really prepared going into that exam. I mean, like, there's only so many things that they can ask you, like, there's only so many like types of questions. So with Maths Advanced, revision is key, and just looking at questions is super important. So all of you guys have made a great first step in joining us today for today's HSC Maths Advanced lecture. So a little bit about me. I'm Alice. I'll be your lecturer today. I graduated in 2022 with an ATAR of 99.3. I am currently studying my first year of medicine at the University of Newcastle. So if any of you guys are interested in studying medicine, I would definitely say Newcastle's the way to go. Albeit I am biased, so of course I'm going to say Newcastle, but just if any of you guys are interested. So during my HSC, I did 10 units. So bio was 2 units, echos was 2 units, English was 2 units, Maths Advanced was 2 units, and 2-unit religion was 2 units. And those are all my marks sitting there as well. So I did get 95 in maths in 2022. So I have a lot of tips and tricks. I did this. Like, I know what situation you guys are going through, and I know how daunting sitting a maths exam can be. So I'm just here today to ease a little bit of your stress and to give you some more exposure to question types. And then if anyone's interested, I do tutor these subjects with TutorSmart, which is the HR Notes tutoring company that I discussed before. And I run the advanced HSC Maths class. So if any of you guys are interested and want a little bit more support going into your trials or the HSC, feel free to check that out. Okay, so your current situation. For most of you, you're probably getting ready for your trials. And then eventually you're getting ready to sit your last ever maths exam, which is super exciting, which is the HSC eventually. I like to think of that as like a really exciting time rather than like a daunting time. Like, I try not to focus on the fact that you have to sit the HSC, and more so think about the fact that like you're going to see like all the work you've done for the past 2 years pay off in that one exam. So that's super fun. This lecture is looking more at preparing you for your exams by exposing you to different types of questions for each of the topics. So you can see the topics down the bottom. So there's trig, calculus, S plus S stands for sequences and series. Then you've got statistics, functions as well. So this is all about just exposing you to really common question types and some tips and tricks about approaching questions for maths in general, as well as like tips and tricks for looking at specific topics and specific question types. So I guess that's the focus of this lecture, rather than focusing on learning the content itself. So it's just more about preparing you for what you'll see and what you should be expecting. So if you want to focus more on the content, at the end of these slides, you can download them. There will be some extra stuff that focuses on the contents rather than the questions, or you can check out some of the past Maths Advanced lectures for the HSC if you want to focus a little bit more on learning content. Okay, so I guess I kind of spoiled it. I already talked about the topics that we're looking at today, but the first thing we're going to look at is just a bit of the exam structure for sitting your trials and your HSC. So you'll be looking at topics, trig, calculus, sequence and series, stats, and functions. And then I guess at the end, we'll be looking at some specific exam tips for studying for maths, because maths is quite different for most of you from the rest of your subjects. I guess you're doing physics. I guess it's kind of similar to physics, but yeah, for most of you, maths is a really different sort of approach in regards to studying. So we'll talk about that. And today's lecture, we're going to be using real questions that have appeared in HSC and trial examinations. So it is the sort of thing that you guys should be expecting to see. And if you guys can all work through today's questions with me, then we'll be good. There is a chat function in this lecture if you guys are watching it live, so feel free to use that. And yeah, we'll just move on to framing the questions. And I guess looking at questions in HSC maths. So I guess it's super obvious, but the first thing you want to do is understand the question. Now, this seems really obvious, but I think this is where a lot of people go wrong, and where a lot of people lose their marks on, is just not understanding what the question is actually trying to ask you. So the first thing you want to be looking at is what variables exist within your question. Like variables in terms of like height, weight, length, sorts of those things. Also, what variables might come in the form of like X, Y, Z, whatever the letter they want to give you. So what sort of things are changing? Then you want to look at hidden information, or like what assumptions the people writing the exam want you to know. With this, there's different sorts of assumptions. So there's like sort of like common sense sort of assumptions that like, if they're talking about a deck of cards, they're talking about 52 cards. Unless they specify otherwise, if they're talking about a dice, they're talking about your regular 6-sided dice that has like 1, 2, 3, 4, 5, 6 on it. So there's those sorts of assumptions. Then there's also assumptions that they're trying to help you make given the information that they give you. A lot of the time this happens, I guess, in the form of they'll give you like question A, B, C, D, and then it's assumed that you know that to answer part C, you'll need to use what you did in part A or part B. So there's those sorts of assumptions, and I think a lot of the time people forget that like those questions don't exist in isolation. If it's part A, B, C, usually they have at least something to do with each other. So if you're finding it really hard to like answer a question and you're thinking like, oh my gosh, like no way they haven't given me the information I needed, likely they have. They've just made you find it yourself in part B, or part A, or whatever it is. And the other really common place that people miss information, and I wouldn't so much say this is hidden, it's just sort of something that people don't think about so much, is thinking about stimulus information that they give you. So again, this happens really commonly with questions where there's like part A, B, C, where it'll be like, say it's question 20, and then they'll give you some stimulus information, like a table of something, maybe they give you like a table of Z scores, and then there'll be part A, and then there'll be part B, and then C or D or E or whatever they want to go up to. And people forget that stimulus information can help you for all those parts of the questions. It's not just for part A. That stimulus might come back and help you for part B. So yeah, just got to make sure that you're thinking about all the information that they're trying to give you. And then you want to also be thinking about what's your answer going to look like. Now, this is a really important step that I think a lot of people don't think about too often. But you want to be thinking about what will my answer look like, So if you've got just like your basic integration question and they're just asking you to like integrate something, you're going to end up with a number. It's going to have like X's in it, or Y, or whatever letter they give you. And so that's what your end answer should look like. If you've got like an optimization question, most likely your answer will have units in it. So it'll be like, find the maximum area of, this like field, and your answer will have to be something meter squared or centimeter squared or, whatever they've given you. So thinking about what your answer is going to look like at the end often really helps you think about, okay, so then what do I need to do to get there? And I guess that sort of links us to the second part of approaching questions in maths, and that's to recall anything and everything that you think you might need to get to that final answer. So there's like relationships between concepts, formulas, methods, steps, anything you need to get the final answer. With this, I think thinking about formula is super important, and just remembering what's on your formula sheet. because you don't want to waste your time studying and trying to remember all these formulas if they're gonna be on your formula sheet anyway, because that's just a waste of time. So you want to get really used to using your formula sheet. And I guess along those same lines, you want to think about what formula on that formula sheet am I not going to need at all. You'll see like there's a lot of formulas that have nothing to do with HSC Maths Advanced. They're more for Extension 1 or Extension 2. So just thinking about like, okay, you know, when I'm looking at page 4, don't need any of that of your formula sheet. On page 3, like when you're looking at like your integration and your differentiation formulas, thinking about like, okay, which ones of these don't I need? Because you don't want to waste time in your exam flipping through this formula sheet just to waste time because you're looking at things that you've never actually used or never seen before. So yeah, just getting super familiar with using your formula sheet. And then I guess the obvious part, looking what methods and what steps do you need to get to the final answer. So that the methods and steps will come from thinking about past questions, like, you know, when I saw a question like this before, what did I need to do to get to the answer? And that's how you get your steps to get there. Part 3, I guess is the obvious part, solve it. Step by step, go down the page. Super important that you set this out nicely, that you are going down the page, you're not going like left or right or anything like that. Because you want whoever's marking it to be able to really clearly see what you were trying to do. Like you want it to be really obvious how you got from this line to the next line to the next line to the next line. When people are marking exams in HSC, like they are trying to give you marks. Like they're not trying to be mean and take things away. Like they're trying to look like, where can we give this person marks? So if you've set your working out nicely, it's really clearly visible to them of what you were trying to do, and it helps them think about like, okay, we can give marks for this because they've shown what they're trying to do here. And then finally, the 4th step is to check. This is where I think if you're not doing this, you might start to lose those little marks here and there because you don't notice that you've, like written down the wrong formula, or that you don't notice that little miscalculation. So super important that you go through and you check just to make sure that those little things are right. Yeah, I think it's just like a lot of people don't check, they feel confident with their answer and then they just never go back and look at it. But, you know, they've accidentally written down like a plus instead of a minus, and then all of a sudden everything after that line of working is wrong. So just going back and checking for those little things can be so good in helping you get those extra marks. So yeah, just like making sure you do that, and then looking for like those slight miscalculations. I know like when you're in an exam, it can be super stressful. And, you know, if you're not thinking properly, you know, you might accidentally write down like 4 plus 7 is equal to 12 instead of 11. So those sorts of things are the sorts of things that you want to be going through when you're checking. Now, when you're checking your answers, this might not happen straight after you do the question. If you know you're a bit short on time, then you want to go through, answer all the questions, and then come back and check. But hopefully all of you guys should be working towards at least having some time at the end of your exam to go through and check for those sorts of little mistakes that you might have made. So I would next want to talk a little bit about summaries. If you haven't started writing your summaries yet, don't panic, don't fear. It's never too late. You just want to be thinking about writing summaries for each of like the topics you learned. So each of like your new formulas, each of like your new like concepts. You want to be just sort of trying to think about like what theory sort of is relevant for that, and like what theory am I going to need to look back on. So anytime you're doing a summary, you're thinking about what am I going to want to look back on and still remember, or like still be thinking about. And then you want to be including a worked example. These things are so good because if you forget how to do a question and you've got your summary, you can go back and look at like, oh, like I've got a worked example for this question, this sort of question type, and this is how I need to answer that question. So super good things to go back and look on. But like I said, if you haven't started, why not start now? So like I said before, this lecture is a lot about question types for each of your topics. So follow me with the throughout the lecture. And you can start writing down some of your worked examples for your super important concepts. because there'll be heaps of questions in this lecture that you'll see are really similar to the questions you get in your trials or your HSC. So if you've got an example to look back on, you'll be able to answer those questions with ease. Okay, so the next little part of our overview is just looking at the hierarchical map, which I guess is just a way to think about your maths syllabus. So when you've got your hierarchical map, each time you go down, you're getting more and more specific, right? So, calculus is your broad topic. Differentiation within that is like, your first sort of specification. Then within that, you've got the product rule, which is again like another specification of a type of differentiation. And then you've got another specification of the cross method solution for the product rule. So when you're looking at the hierarchical map, the further you get down, the more likely it is that that's sort of what your questions are going to be targeting. So what I mean by that is like when you've got calculus, like your questions in your exams aren't going to target like calculus as a whole. They're more so going to look at the product rule or the cross method solution, right? So the more you go down, the more specific something is, the easier it is for people to write exam questions on those solutions. So when you're looking through the syllabus when you're studying, you want to be thinking about, can I answer each of the specific points within the syllabus? Or like, could I answer a question using the product rule, for example? And that'll help you make sure that you're super ready to sit those exams and you're ready for all the different types of questions that they might ask you. Because I guess going into your exam, you want to be absolutely as ready as possible, as you could possibly be. So just making sure you can look at all those specific points of the syllabus as you go down the hierarchy of the map will really help you just be focused and ready to go into that exam. Okay, so I guess the next thing we're just going to quickly talk about is the logistics of doing a maths exam, a 3-hour maths exam. So for most of you, your first 3-hour maths exam will be your trial. And that can be super, super daunting, but like I promise you, it's not that bad. Like I feel like once you get into the exam and you're sitting in your exam room, like you sort of forget that it's 3 hours. Like you just work through the questions and like all of a sudden you've only got like 20 minutes left, So yeah, it's a 3-hour exam. You do get 10 minutes of reading time at the very beginning. Reading time in maths, I think, is quite different to other subjects. Because it's not like you're thinking about, I guess, like what content you need to include in each of your questions. You're sort of just reading those questions to get a bit of an understanding about like how difficult the questions are going to be. And I think that's probably the best way you can use your reading time, is to think about like which questions are going to be the most difficult for me. And if you're thinking about, there's maybe 5 questions that you think you're going to find really difficult, you need to make sure that you're allocating yourself enough time and a bit of extra time to be able to answer those questions. And you'll also read through and you'll be like, oh, like this is a pretty easy question for some of them. And you think to yourself, okay, I won't need to spend as much time doing that. So yeah, just using that reading time to think about difficulty of questions and planning how you're going to attack that paper. So your 3-hour exam's 100 marks. So that's pretty stock standard for a 2-unit exam in the HSC. So that's nothing new. And then this is the part that I feel like scares a lot of people. 30% of your exam does come from year 11 content. Now, I think a lot of people get really scared about this and think that they have to go and revise all of the year 11 content. But let me tell you, that's not the case. You want to be checking out some of the year 11 lectures. They're not too long, and looking at those lectures will help you just get like a broad picture of what you want to be remembering from year 11. But you don't want to spend too much time focusing on that year 11 stuff, because all in all, 70% of your exam is still year 12. And with that year 11 content, I think a lot of people forget that a lot of that content you come back to in year 12. Like I think sometimes people forget that like the first time you do differentiation is in year 11. So that's considered like your year 11 content, right? So it's not stuff that you're not going to have looked at since you did in year 11. It's not going to be that super random, really niche topic that, they ask you about like once in one exam in year 11, right? They're going to be looking at what stuff from year 11 is relevant to the stuff we're also assessing in year 12, okay? So don't stress about that stuff. Don't want to spend too much time looking at your year 11 content, because more of your marks are coming from year 12, right? So this is the sort of thing that you'll see on the front of your exam. It's the same for every maths exam that you sit. It's just giving you like the breakdown of the marks. So you've got 10 marks for multiple choice, questions 1 through 10. With these questions, usually questions 1 to 7 or so are pretty stock standard maths questions. They're just like applying a formula, recalling a rule, sorts of simple maths questions. And then usually it's around question 8, 9, 10 that they start to become a little bit more questions that you've got to think a little bit more about. And not to say that they're too tricky or anything. I think they are still very answerable questions. They just require a little bit more thought to go into them. And then the bulk of your paper, so the other 90 marks, are your short answer questions. Most of them do have multiple parts. So it'll be like, question 11A, 11B, 11C, and like 12A, 12B, 12C, 12D. So they are super related to each other. You don't get too many questions, I guess, that exist in isolation. You do get a few, but not too many. And as you go through the paper, your questions typically increase in difficulty. So, question 11, which will be the first question, short answer question after your multiple choice, is usually fairly simple short answer question. And then your last question is typically the hardest question in the paper. So that's typically, if you're really familiar with whatever they're trying to assess as the last question, you might find the last question super easy. Or, if you're not as familiar with what they're trying to assess in question 11, then, maybe that'll be a bit harder. But in general, they are designed to get harder as you go through. So you don't want to be sort of thinking about that when you're thinking about, I guess, how you're going to approach the paper. If you're going to spend more time in the second half of the paper than the first half, because your time is not going to be split up proportionately. So you just want to keep that in mind, I guess, when you're thinking about how you're going to approach your paper. But anyway, so this is, I guess, the overview of the topics in HSC Maths. Pretty chill, pretty relaxed. You've got functions, and within that comes your graphing. You've got trigonometric functions, which comes trigonometric functions and graphs. Calculus is sort of your biggest bit here, because within that you've got differentiation, applications of differentiation, and integration. And this will form a lot of your paper comes from calculus. Then you've got financial math, which is about modeling financial situations. Something to note is that this is also where your sequences and series come in. I think sometimes people forget that sequences and series exist because they're not specifically outlined here, but they are part of financial maths. And then the last little bit is you've got statistical analysis. So you've got your descriptive statistics and bivariate data analysis, and then you've got random variables. So yeah, that's an overview of the topics we're going to be looking at today. You can see them down the bottom as well. So yeah, we're just going to be covering sort of those topics and questions that you might find in each of them. Okay, so onto the maths now. The first topic we're going to be looking at is trig. I think a lot of people, I guess, like trig. I think that's probably because you start looking at trig pretty early in high school. And you just sort of slowly builds up on your trig until you can get to the point where you can do your year 12 trig questions. Trig does make up a fair few bit of your paper, so you do want to be super familiar with it. Okay, so just a quick, I guess, little side note. These questions that we look at will have a little bit of a difficulty rating on the side. I have tried to include mostly what I would consider like a difficulty level of 3, just so you guys are exposed to like the harder questions, because I think a lot of people focus on the easier questions when they're studying. So I thought let's look at the harder ones today. And then with each of them, just looking at a little like what syllabus point, I guess, relates to that question. Okay, so this question is from the 2018 HSC paper, so it's question 15. And the syllabus point it's most relevant to you guys is use trigonometric functions of the form k multiplied by f of a times x plus b plus c to model and or solve practical problems involving periodic phenomena. Super, super, super common question to get. And they always, not always, but really commonly, these questions come up as sunrise to sunset or tides, like the tide of water going up and down. A super common question type to see, so super important that you guys know how to do this one. Okay, so the length of daylight, which is the function L of t, is defined as the number of hours from sunrise to sunset and can be modeled by the equation L of t is equal to 12 plus 2 cos all on 2 pi t over 366, right? So with that, t is the number of days after the 21st of December 2015. For 0 is less than or equal to t, which is less than or equal to 366, right? So I'm just going to give you guys a second to like read that again to yourselves. Okay, so then we've got part I, which is find the length of daylight on the 21st of December 2015. So for right now, we're just going to look at part I. That's the only part we really care about right now. So let's think about finding the length of daylight on the 21st of December 2015. So 2015, December 21, is our start date. So at that date, t is equal to 0. So what we're finding is L of 0. So then what we want to do is just plug that into our equation. Right, so if we put t into our equation, this is what we're going to get. And so we're going to get 12 plus 2 cos 0, because this little bit here will equal 0, because when we're multiplying anything by 0, we're going to get 0. So our numerator will be 0, which will make our whole fraction equal to 0. So then we've got equals 12 plus 2 times 1, which is equal to 12 plus 2, which is equal to 14. So therefore, the day is 14 hours long. Right, and that's all we need to do to get part I. Right, so with this one, we just need to make sure we're identifying if it's the 21st of December, our variable in this situation is t. So on this date, what is t going to equal? And it says we know that 21st of December is our start date, so t is equal to 0. Okay, so then we want to be looking at, for part II, what is the shortest length of daylight? Okay, so I'm just going to give you guys all maybe 10 or so seconds just to think about how we might be approaching that question. Okay, so when we're looking at what the shortest length of daylight is, we're thinking about being between 1 and -1, right? When we're thinking about our shortest length of daylight impacting our amplitude, okay? So if we didn't have this 2 here, our amplitude, so like how our graph's going up, how tall it's going up, how short it's going down, is just 1 to -1, just based on our basic cos graph, right? But let me erase that. But because we do have 2, we need to be thinking about how that's going to impact our amplitude, right? So if we just had this without the 2, this is how we would be looking at finding the shortest length of daylight, because our shortest length of daylight is going to happen at the lowest point on our graph, right? So if we didn't have that 2, this is what we would be looking at. Now, similar to how you would change your domain and range when you're looking at your trig functions, like solving for a trig function, that's what we need to do to this, right? So what we want to do is have 2 cos 2 pi t 366 in the middle of this notation for our domain, right? And so what we've done to the middle is times it by 2, right? To get from here to here, we've times it by 2. So we're going to do the exact same thing to either side. And we're going to get -2 to 2. Right? So that's thinking about our amplitude. So we got to then think about which side is going to give us the shortest length of daylight. Right? And then when you think about that, -2 equals 2 cos 2 pi t on 366 will give us the shortest length of daylight. Right? Because -2 will be our low point. Right? And our lowest point is where we're going to find the shortest length of daylight. So then the next thing we want to think about, just quickly change color, is then solving, right? We want to solve for 2 cos 2 pi t on 366 is going to give us -2, right? So what we want to do is we've got our equation, which is L of t is equal to 12 minus, well, let me check if it's minus or plus 2 cos 2 pi t on 366. And then we've just said when 2 cos 2 pi t on 366 is equal to -2, that's when we're going to get our shortest length of daylight. So then what we're going to do is then sub in what we've said is going to be here, which is our -2. So we're going to get 12 equals -2. Oh, sorry, 12 equals 12 minus 2, which is then equal to 10 hours. So we say, therefore, our shortest length of daylight is 10 hours. Right, so with these questions, when they're asking about what is the shortest length of daylight, they're asking for like an actual thing, you do want to be giving, I guess, not really a sentence, but like a worded at the end, you know, like, therefore the day is 14 hours long, or like, therefore the shortest length of daylight is 10 hours, and actually write that out rather than leaving it here. So yeah, that's all we needed to do for part 2. I think sometimes people get a little bit confused with these sorts of questions with not realizing that you can sub this in up here, and then like all of a sudden they're trying to like solve this for t, but we're not finding what day is it going to be the shortest length of daylight, right? So if we were finding what day, then that's when we'd want to solve for t, but we're not. We're trying to find what is the length of daylight when it's the shortest, right? So this is when it becomes really important again to think about your variables and to understand what each of your variables means. Because in this situation, if you know you're not going to solve for t, you won't make the mistake of getting here and then trying to solve that. Okay, so then that's part 1 and part 2 done. And then we've got, what are the 2 values for t for which the length of daylight is 11? So again, I'm just going to give you guys a couple seconds to think about that. Okay, so, oh good, I was worried I didn't put a slide in to answer this question, but I did, so we're good. Okay, so when we're thinking about this sort of question, well, let me get back. This is when we are solving for t, right? So we understand that the variable we are most interested in right now is t, okay? And we're looking at for which the length of daylight is going to be 11. Okay, so they've given us that LT is going to equal 11 in this situation. And we want to solve for t. Okay, and so this is the sort of question when we're now thinking about our trigonometric function itself and how we can go about solving that. So I'm just going to change colour so you guys can see it. So this is when we go 11, which is the LT that they've given us, is going to equal 12 minus 2 cos 2 pi t on 366. Let me just check that I wrote that down right. Again, this is when we come into checking, making sure you're writing down the right thing. 12 plus 2 cos pi. Okay, cool. Oh, no, I didn't do it right. That's plus, not a minus. Okay, and so then this is where we are now trying to solve for t, okay? First thing we want to do is minus this 12 across. So we do minus 12 on both sides, and we're going to get minus 1 is equal to 2 cos 2 pi t on 366, right? And then another easy thing that we can do is to take this 2 across, divide it, so then we're going to get negative 1/2 is equal to cos of 2 pi t on 366. Now, this is when you get the negative 1/2 and you're thinking about, okay, like I know that there's going to be one of our exact ratios here because we've got 1/2, right? So I want everyone to think about in their heads, or if you've got a formula sheet with you, it's on your formula sheet, that exact value triangle, and think about what is going to be the value of cos when it's equal to negative 1/2. Then you're going to have to think about the all stations to central, that little diagram. I'll actually just draw one down for you. Stations to central. Okay, so if we've got cos is equal to negative 1/2, then we're going to be able to say that 2 pi t on 366 is equal to 2 pi on 3 or 4 pi on 3. Super, super important you remember that it could equal either of these things because there are 2 quadrants in which cos is going to be negative. Okay, so important that you guys remember that cos is going to be negative here and here. Because if you only remember one of those angles, you're going to end up with only one answer. But the question, we've got to remember, the question is asking us, what are the 2 values of t, for which the length of daylight is 11? That 2 is also an indicator that you don't have to keep going round and round and round and round and round. They only want you to do the first 2. Okay? So then we want to solve for each of these. So if we've got 2 pi t on 366 is equal to 2 pi on 3, then we can pretty much go, okay, we can cross these out on both sides, And then what do we want to do? Then we can go t is going to equal 366 on 3 if we move all those around properly, because we're going to multiply that 366 across. So then that's why we're going to get 366 on top, and the 3 is still in the denominator. And then if you work that out, 366 divided by 3 is 122. That's a whole number, so that's pretty good. 122 days. Remember, this is when we're thinking about what is our solution going to look like. 122 days after, December 21. And then we're going to do the same thing with our second solution. And then we're going to get 4 pi on 3. And then with this one, we can cross our pi's out on both sides. Then we're going to do t is equal to 2 times 366 on 3. Okay, and then if we work that out, we'll just use a calculator really quick. Then we're going to get 244 days. Okay, and then we've got, I'm just going to write this one more thing. Therefore, t will equal 122, or 244. Okay, and then that's how we solve for part I. Okay, so this is a difficult question, but it's also the sort of question that, like, if you see it enough times, like just using different values, you do get super used to answering them. Super common trig question that all of you guys should be familiar with. Okay, so this one's a little bit easier, I think. So this one I would say is probably like a 2 out of 3 difficulty. And we're looking at the syllabus point. Use trigonometric functions of the form k times f of a x plus b plus c to model and or solve practical problems involving periodic phenomena. Okay, and this question is just find all solutions of 2 sine squared x plus cos x minus 2 equals 0, and the domain 0 x is between 2 pi and 0. So I'm just going to give you guys all just 20 seconds just to think about this. Yeah. Alrighty, well, we'll just look at this. I actually might just write the solution underneath this so we can still see the question. Okay, so with this, we are trying to solve, but what we were trying to do, we need to find something to solve for, right? We want this all to be in terms of just one variable, because we don't know how to solve for x if we've got sine squared and cos. We want it to be just sine or just cos. So the first thing we want to think about is how can we change one of these to be like the other one, right? So this is something super important about manipulating one of the formulas on your formula sheet. And this will be the hardest part of the question, is doing this first step. So hopefully you guys are all familiar with the formula. Sine squared x plus cos squared x is equal to 1. Right? So from that, we can then say that sine squared x is equal to 1 minus cos squared x. Funny how that works when we've got sine squared x as one of our parts of the question, right? So then that's when we can then, just do this in a different color, we can then say, okay, that equation is equal to 1 minus cos squared x plus cos squared x minus, not cos squared x, just cos x, sorry. got a bit carried away. Oh, I just wrote it wrong too. Okay. I'm not doing so great on this question so far. Cos squared x minus 2 is equal to 0, right? And now all of a sudden we've got our variables in terms of one another, right? We want only one trigonometric function. Okay, so then if we expand that, 2 minus 2 cos squared x plus cos x minus 2 equals 0. And then these will cancel each other out. And then we get minus 2 cos squared x plus cos x is equal to 0. Okay, super important that you don't make the mistake of trying to add this into this, because they're not like terms, right? Cos squared is not the same as cos x, right? Just like if we had x squared plus x, we couldn't add those together, right? So super important you don't fall for that common, I guess, like mistake that people make, right? Okay, so then what we want to do is think about how can we find something that we can then use to get an angle, right? Whenever we're looking at questions solving trig functions, we're thinking about how can we find an angle in terms of our or stations to central, right? So then, just like you would do if I gave you, I'll just quickly write this in different colors so you don't get confused, minus 2x squared plus x, just like you'd factorize that, we're going to factorize this expression here. Okay, so we're thinking about, okay, what's going to be common? And common between them is cos x. I'm actually going to flip these around so we've got this term first, just so we don't have a negative at the front. So cos x times 1 will give us this cos x down here, and then cos x times minus 2 cos x is going to give us minus 2 cos squared x, okay? And then from here, we can then have two solutions, just like we would have if you did this with x's. You'd then get cos x equals 0, or you'd get 1 minus 2 cos x is equal to 0, right? Because if we're multiplying these two terms together and they're giving us 0, at least one of our terms has to equal 0. Okay, so if we've got cos x equals 0, then we know that our x is going to be pi on 2 or 3 pi on 2. Okay, and then if we've got 1 minus 2 cos x, we need to do a little bit more manipulation to that. So we're going to get minus 2 cos x is equal to minus 1. So then cos x is equal to a half. And then if we've got cos x is equal to a half, we can then, again, thinking about our exact value triangles, think about x is equal to pi on 3 or 5 pi on 3. Again, with this question, super important to remember that there's more than one solution, okay? Because cos x, if it's half, it's positive. So it's positive in 2 of our quadrants. Okay, I'm just going to scroll down to the next page so I've got some more room. Okay, so then we just have all of our solutions, and what we want to do is order them. So we're thinking about, oh, actually don't need this much room because we're nearly done. X, therefore, is equal to pi on 3 times pi on 2, not times, pi on 2, 3 pi on 2, and 5 pi on 3. And that brings us to the end of that question. Now with this question, that's all we have to do because all we're doing is finding solutions, right? These solutions don't have like any, I guess, like value attached to them. Like they're not tides, they're not times, they're not sunlight, they're not anything. All we're doing is finding solutions. So that's why we can just leave those in terms of x. So again, with this sort of question type, super important question to come up. So this one's from the 2014 HSC paper. But even if you look like through the most recent HSC papers, you'll see at least one question somewhere that's about solving a trigonometric equation. So yeah, super common question type. And again, if you know how to approach it, and you know like the methods and the steps that you need to be remembering, then you'll be able to get these marks easily. Okay, well that was the page I was going to do for the solution, but anyway, that's it for our, I guess, quick revision session on trig. The next topic we're going to be looking at is calculus. So that's super fun. I'm hoping that everybody loves calculus. Yeah, anyway. Calculus is just one of those things that you love it or you hate it. There's no in between. Okay, so this is from the 2021 HSC. So this is after they did the new syllabus for maths. So it's question 24. I'd probably say this is a 3 difficulty. So we've got the curve y equals 3 over x minus 1 intersects the line y equals 3 and 2 times x at the point 2 and 3. Okay, and they give that to us. The region bounded by the curve y equals 3 over x minus 1, the line y equals 3 on 2x, the x-axis, and the line y equals 4 are shaded in the diagram. Find the exact area of the shaded region. Now, this sort of question, I guess they were nice to you in the fact that they give you the diagram here. I would say biggest tip, if they don't give you the diagram, the very, very first thing you want to be doing is drawing that diagram yourself, right? Because otherwise it's super hard to understand what they're actually trying to get you to look at, okay? And if you can't see this diagram, so if they didn't give it to you, you wouldn't be able to see that because this line is exactly perfectly straight, we can then do a little triangle here, okay? Because if we've got all these different lines, we can't integrate all of them to find our exact area under the curve. So we need to find some way to split it up so that we can do some integrations and finding out the area, right? Because if I gave you all of this, I don't think anybody here would know how to just integrate all of that to find our exact area, right? So if we can make a triangle, everybody knows how to find the area of a triangle. So that's something super easy that we can do to then find some of the area, right? Because we are finding exact area. Okay, so to find this area of the triangle, area equals half times base times height. So we know that our base is going to be 2 because our x coordinate here is 2, so we know we're going to be 2 in. So we're going to get half times 2. And then our y coordinate is 3, so we know we're going to be 3 units up times 3. So we're going to get 2 times 3 on 2, which is 6 on 2, which is 3. Okay, and then that's here. Alrighty, for this next bit, I'm just going to do it down here because we're going to need a little bit more room. But this is when we can then start to do our integration because we're only thinking about, let me just draw it, 2 lines, right? We can integrate for our area when we are only thinking about 2 lines. Okay? So I'm actually going to make this blue so it makes a little bit more sense. So then we're thinking about, we've got between 4 here and 2 here. So we're going to be integrating between 4 and 2. And we're integrating to find the area between 4 and 2 of just this function, right? Some people get a little bit confused, I think, about knowing which formula they're doing or which function they're looking at, if they have to like minus them or add them together. But in this situation, this line here, this x equals 4, the only thing it's doing is creating a boundary, right? Because there's no area between that line and the x-axis because it exists vertically, right? So they're only looking at the area under this curve here, okay? And then what we want to do is just integrate that using the formula sheet when we've got what do you call it? A fraction like this. So then we're going to be thinking about, we're going to get 3 ln x minus 1 and 4 and 2, because what we want to do is then take this out. So to get from here to here to here, sorry, I probably should have done that a little bit better. Then we do 1 on x minus 1. So we've got, so this is going to equal f dash x over f of x, right? So in order to do that, we need to place that 3 on the outside, so we're not actually changing the function itself. Okay, and then we're going to integrate that, and we're going to get, actually we know what we're going to do. Then to find the exact area is when we're combining these two things together, right? Because those give us the 2 halves, well, not exactly half, but the 2 areas that we're trying to find. So then the area is going to equal to 3 plus 3 ln, whoops, I forgot the L, x minus 1, should make this a bit harsher, between 4 and 2. And then when we look at that, we're going to get 3 plus 3 ln 3. And again, we're finding area, so units squared. Okay, I'm just going to give everybody like just a second just to absorb all of that. Okay, so yeah, I'd say that's a pretty difficult question. I would say that most of you are probably pretty confident with doing the maths itself, like doing this, finding the area, and then, you know, integrating. Just the hardest part is understanding what we actually are trying to find the area of and what we need to integrate. Okay, so don't be afraid to take some time when you're starting a question to actually be thinking about what am I actually going to be doing here? Okay, like it's okay to take a second just to think about what am I actually finding the area of, right? Okay, so this is also from the 2021 HSC. I'd say this is probably a 2 on my scale of difficulty. So I'm just going to give you all a second to read that question. So we are solving optimization problems for any of the functions covered in the scope of this syllabus in a wide variety of contexts, including displacement, velocity, acceleration, area, volume, business, finance, and growth and decay. So they've just pretty much listed off every possibility of a question type you can look at, okay? So super common way that this does come up is in terms of particles. So you think about a particle is shot vertically upwards from a point 100 meters above ground level. The position of the particle y meters above the ground after t seconds is given by yt equals minus 5t plus 70t plus 100. Now I think optimization is one of those things that you never really know what to expect. And I wouldn't say that's particularly true. I think there are patterns to your optimization questions. So it's just super important to do a lot of practice with these sorts of questions so you know the sort of thing that might come up. So if we're looking at part A, find the maximum height above ground level reached by the particle. Key giveaway here is when it says maximum height that we are going to be differentiating to find, in this case, y dash. So if we've got yt is equal to minus 5t squared plus 70t plus 100, we're just going to quickly differentiate for y dash, which is going to give us 2 times minus 5 is minus 10 plus 70. So it's a pretty simple differentiation. So you'd probably get 1 mark for doing the differentiation correctly. And then all we need to do is max height is when y dash t is equal to 0. Okay, so then we're going to get minus 10t plus 70 is equal to 0. So minus 10t is equal to minus 70. So then t is equal to minus 70 over minus 10, which is equal to 7. Okay? And then we need to find yt when t is equal to 7. Some people, is really common for some people to forget that there is one more step in this process. Okay, so we found the value of t for which we're going to get the maximum height. But in order to find that height, we need to find yt. Okay, so we're going to find y when t is equal to 7, so y of 7. So that's going to give us minus 5 times 7 squared plus 7, 70 times 7 plus 100, which is going to give us, I'm just going to use a calculator quickly to do this. If everybody wants to give this a go on their calculator too, they can. Okay, which is going to give us 345 meters is the max height. Okay, so that's a pretty stock standard question, optimization sort of question. So you do want to get super familiar with finding maximums and minimums in all sorts of contexts. So then we've got part B. Oh, I didn't leave enough space to do part B. Okay, we're just gonna quickly rub this out and then we'll do part B in there as well. Okay, so with part B, it's worth 3 marks. So you do want to be familiar with how to do these questions because you don't want to be losing 3 marks in your paper. And there's usually at least one question on optimization in your paper, so it's super important to get familiar with them. Okay, so find the velocity of the particle in meters per second immediately before it hits the ground, leaving your answer in the form A, just times the square root of b, where a and b are integers. So this question, automatically they're giving you what they want their answer in, and velocity is our key giveaway that we want to be finding. We're still going to be using our y dash. Okay, so to find when the particle hits the ground, we want to find when yt is equal to 0, right? Because if yt is our height, if we have no height, if it's equal to 0, then we have nothing. It's going to be on the ground. Sorry, that was a long way to go about saying that. But anyway, so we're trying to solve for minus 5t plus 70t plus 100 is equal to 0. Okay, first thing we want to do here is simplify. So we can simplify by dividing by 5. Actually, we'll divide by -5 to get rid of that negative up the front. So obviously if we divide this one by -5, we're going to get just the t squared. 70 divided by -5 is -14. And then we're going to get -20. So with this, the key indicator here that we're going to be using the quadratic formula is that they've given us this with a square root. And what way of solving a quadratic is going to give us a square root? The quadratic formula. Okay. So then if we solve for that, we're going to get 14 plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is going to give us 14 plus or minus. Just going to quickly work that out. If everyone wants to give this a go on their calculator as well. Okay, which is going to give us square root of 196 plus 80 on 2, which is equal to 14. Actually, we can simplify that. If we do this division here, we'll get 7 plus or minus the square root of 69. Okay, so then we've got to think about this. This is a super common thing that people forget to think about when they're doing these sorts of questions, is that we are looking at time. So our time won't be negative. So therefore, that t is only going to be 7 plus the square root of 69, because we're not interested in the negative, because we're not going to have negative time. Okay, then what we want to do is find when we've got y dash of 7 plus 6 at the square root of 69, so that we can get our a and our b, so that we're looking at velocity, right? Because if we're looking at velocity, that's why we want to be thinking about y dash. And then we've got the t that we need to put into that. So if, I remember we said y dash of t was equal to negative 10t plus 70. So if we've got y dash of 7 plus root 69, we're getting negative 10, 7 plus root 69 plus 70, which is going to give us negative 70 minus 10 root 69 plus 70. So we can cancel those out, and we're going to end up with negative 10 to the square root of 69. Okay, and they've told us that they want our solution in this format. We can look at our solution. We're in that format where a is equal to negative 10 and b is equal to 69. Alrighty, so that's that. And that's like a super common calculus question. So they're not too difficult if you know what you're sort of looking for. So you don't want to get super familiar with those sorts of questions. Okay, our next topic, sequences and series, which was personally probably like my favorite topic in HSC maths, not including financial maths. I did not particularly enjoy the financial maths part, but the sequences and series itself. So this is a hard question. And yeah, like you just want to give yourself a lot of exposure to these sorts of questions. So we're going to be looking at question 16 from the 2014 HSC maths paper regarding the syllabus point, solve problems involving compound interests, loans or investments. Okay, so at the start of a month, Joe opens a bank account and makes a deposit of $500. At the start of each subsequent month, Joe makes a deposit which is 1% more than the previous deposit. At the end of every month, the bank pays interest of 0.3% per month on the balance of the account. Explain why the balance of the account at the end of the second month is this. Super common question they're going to give you, okay? So for part I, so at the very start of the first month, she's got $500 in there, right? That's what she's done. Then at the end of the first month, she's adding her interest, right? That's when her interest is getting paid. Right, so if they're paying 0.3% interest, we're going to have that is going to be as a decimal 0.003, and we're timesing it by 1.003 because we're still going to have our value, our $500, which is why we've got the 1 plus the interest, which is the 0.003. Okay, and it's at the end of the month that the bank pays interest. So then we've got at the start of the second month, we've then got 500, 1.003, so that's what we've got here, plus the 500 times by 0.01, right? Because each time she makes a deposit 1% more than the previous deposit. Okay, then let's think about the end of the second month. We're then going to have all of this is going to be have earned some interest. Right, so all of that's going to have earned 1.003. because all of that she's had at the start of the month will get interest at the end of the month because it's still all just sitting in that account. So then what we want to do is expand this. So we'll get 500 times that across. We're going to get 500 1.003 squared plus the 500 1.01 1.003. Okay, which is what we were trying to get. With these sorts of questions, I think if it's only, 2 or 3 months that you're looking at, easiest way to do it is to just look at what would happen at the start and the end of each of the months. Okay, now this is the really hard part. Find the balance of the account at the end of the 60th month, correct to the nearest dollar. Okay, so we're saying at the end of second month, we've got 500 1.003 squared plus 500 1.01 times 1.003. Okay, so now we want to find what's it going to be at the end of the third month, right? Because we have to do at least 3 months if we want to be establishing a pattern in any HSC question about acuities. Annuities, not acuities. Okay, so then at the end of the third month, we're going to have 500 1.003 squared plus 500 1.01 1.003 plus 500 1.01 squared. And then all of that's going to be times by that. Okay, then we're going to get that out, and then we'll get this. Now, I think a lot of people get a little bit confused with this bit here about why that's squared, but that's because this is the second time we're timesing it again by that 1.01 on the initial $500 deposit. Okay, so then what we're looking at is, therefore, if we've got the end of month n, we've got 500 1.003 n plus 500 1.01 1.003 n minus 1 plus 500 1.01 n minus 1 times 1.003. Okay, so that's what we're looking at when we're looking at this sort of question. So then what we want to be doing is, therefore, the end of the 60th month is going to equal 500 1.003 power of 60 plus 500 1.01 times 1.003 to the power of 59 plus 500 1.01 to the power of 59 times by 1.003, and we'd have all these little bits in between. Okay, and then this is where we've got, it becomes a sequence. So then when we're thinking about this in terms of a series, we all have on the outside this, the term, all times by 1 plus 1.01 plus 1.01 all on this, squared, plus all the little bits in between, plus 1.01 over 1.003 to the power of 59. Okay, then we're looking at our formula for the geometric series, and we get 500 1.003 to the power of 60, all multiplied by, this is where it gets a little bit confusing because we've got all these fractions going on, over 1.003 to the power of 60 minus 1, all over 1.01 over 1.003 minus 1. And then when we do that, it equals $44,404.378, which is equal to $44,404 to the nearest dollar. Okay, these questions are hard, so don't worry too much about them if you still aren't quite getting them. They just are the sort of questions that take a little bit of practice doing. So just try and do as many annuities questions as you possibly can get your hands on. Okay? So then this, I would say, is probably a very easy sequence and series question. So if everybody wants to give this one a go, just think about how you would go about, how we would go about answering this one. Okay. Okay. So this is a pretty simple sequences and series question. Okay, so if we've got in an arithmetic series, the fifth term is 200 and the sum of the first four terms is 1,200, find the value of the 10th term. If they've given us the fifth term and the sum of the first four terms, then we're going to have to use both of our formulas for an arithmetic series. Okay, so if we've got the one for a number of terms, a plus n minus 1 times d. So they've given us that the fifth term is 200. So we're going to get a plus 4d there. And then we've got also Sn equals n on 2, 2a plus n minus 1 times d. And so they've given us that the sum of the first four terms is 1,200. So we've got 1,200 is equal to 4 and 2, which is 2, 2a plus 3d. Okay, and we can simplify that as well by dividing this 2 out. So we're going to get 600 is equal to 2a plus 3d. Okay, so now we've got these two formulas here. So what we want to be doing now is thinking about how can we use these two formulas that we've got, or these two equations, and how can we use them to answer or to eliminate one of our variables so that we can find the other one. Okay, so if we've got 200 equals a plus 4d, and then we've also got 600 equals 2a plus 3d. If we multiply this first one by 2, we can get 2a, which will help us to eliminate a as one of the variables. So then we'd get 400 equals 2a plus 8d. So then if we subtract these from one another, we can get rid of a as a variable. So we get 200 is equal to minus 5d. And then so to find d, we want to get d by itself, so we divide both sides by minus 5, and we get minus 40 is equal to d. Okay, so now that we found one of our variables, the next thing that we want to do is then start to look at how can we put that d, what we found for d, back into one of our equations to then find a, because we do need to find both of our variables in order to find the 10th term. Okay, so then if we do 200 equals a plus 4 times minus 40, we get 200 is equal to a minus 160, and then our a is equal to 360. Okay, so then we can use all of that back in our first formula to find the value of the 10th term. So T10 is equal to 360 plus 9 times minus 40, which is equal to 360. 9 times minus 40 is minus 360. I'm just going to check that with the calculator, just in case my mental maths is wrong. Okay, and then so therefore our 10th term is equal to 0. Okay, pretty simple question. It is worth 3 marks because there's quite a fair bit that you do need to do, but the maths itself is not too tricky. Okay, so our second last topic for today is statistics. Statistics is a pretty fun topic, I guess. I mean, if you like it, you like it. If you don't, you don't. But I do think statistics is pretty fun. So this question for statistics is probably about a 2 in terms of difficulty. So we're looking at the syllabus point. Define the probability as the area under the graph of the PDF using the notation. I'm not even going to try and enunciate this notation, where f of x is the probability density function defined on A to B. Okay, so we've got a continuous random variable x has the following PDF. Here it is. Find the value of k. Okay, so I did leave myself 2 slides, so that's good. Okay, so we want to be finding the value of k. If we know this is a probability density function, we know that when we integrate it, we're going to be getting an area of 1 because that is one of our properties of our PDFs, okay? So we can say that between k and 0, the integral of sine x dx is equal to 1, okay? And then our pretty simple integration, so our integration of sine x is negative cos x, and between k and 0 is equal to 1, okay? Then we just do how we would for any other integration. Cos 0. The reason that this is plus is because we've got a negative here and then we're minusing the second term. That's why we change that to a plus. Equals 1. So negative cos x is equal to 0 because this is equal to 1, and then we're going to minus that 1 across. Okay, so then our cos of k, if we take this across, we're going to get pi on 2. Okay, so then that's all we need to do to get those marks. Okay, so pretty simple, worth 2 marks, super easy marks to get. Then we want to find the probability that 1 is greater than or equal to x, giving your answer to 4 decimal places. Okay, so this is our indicator. We don't want the exact value. Don't care about the exact value for this one. Okay, again, pretty simple question. Just knowing what to do is the hard part. Okay, so what we want to do is find the area under that curve between 1 and 0. Okay, just like we just did for for k, doing the same thing just for 1. So we're going to equal, if we integrate that, same integration, negative cos x between 1 and 0. We're going to get negative cos of 1 plus 1, because we already just talked about before how our cos of 0 is equal to 1. And then if we put that in our calculator, if everybody wants to give a go putting that in their calculator, then we're going to get, it's just about equal to 0.4597 to 4 decimal places. Alrighty, so yeah, pretty simple question. Yeah, I just want to get used to using these PDFs. Okay, so that's that. And that's our quick bite-sized revision on statistics. So now our very final topic that we're all going to look at today is functions. I feel like functions has a bit of everything in it. It's quite a big topic, quite a broad topic. So definitely a lot to look at. So we'll just start, I guess. So this question is from the sample paper that NASA put out in 2020 when they redid the syllabus. So when we're looking at determine the number of solutions of an equation by considering appropriate graphs. Okay, so by drawing the graphs on the number plane, determine how many solutions there are to the equation sine x equals the absolute value of x on 5. So when you get this sort of question, you want to separate these functions. So we're going to have, I'll do this in two different colors so you guys can see them. Y equals sine x, and we'll also get y equals the absolute value of x on 5. Okay, we'll start with y equals sine x because that doesn't have any transformations to it. So we are just looking at, let's see how good, it's already not good, how good my graphing is. Let's see if I can graph this nicely. Okay, I feel like you guys are going to get the vibe. That's probably, actually, I'll complete this. That's that for our graph of y equals sine x. Then when we're looking at the absolute value of x on 5, we're just going to be looking at, there's no transformation, so it's going to start here. In the middle, the absolute graph of x on 5. It's not going to have any other x, y intercepts other than the origin. Sorry, it took me a second to think of what I was thinking of there. Okay, I don't have a ruler, so I'm going to try my absolute best to draw this properly. It's got a steepness, like a gradient of 1 on 5. So I'm just going to try my absolute best to draw this graph. Okay, it's a bit lopsided, but get the vibe. So then we can then say, all we want to do is look at our solution. So where do they intersect? 1, 2, 3. So therefore, there are 3 solutions. Okay, so this is a super common functions question, just about finding solutions based on graphing. And usually at least one of your, in one of your exams, usually in your exam, at least one of your questions will have something about graphing. So you just want to get super familiar with doing that. Obviously, if it was in your exam, you'd want to use a ruler, but I'm drawing on my iPad, so I don't have a ruler with me. But yeah, you'd want to do it a little bit more to scale. But that's the general vibe of this question. Oh, I left a slide to do it, but anyway. This is again from that same paper. So it's looking at the syllabus point, use graphical methods with supporting algebraic working to solve a variety of practical problems involving any of the functions within the scope of this syllabus in both real life and abstract contexts. So the function f of x is equal to the absolute value of x is transformed, and the equation of the new function of the form y equals k f of x plus b plus c, where k, b, and c are constants. The graph of the new function is shown. What are the values of k, b, and c? Okay, so this I think would probably be considered year 11 because you do the majority of this stuff in year 11. Okay, so the first thing we want to look at is we can automatically, just looking at this graph, find out what b and c are. So c is going to be -1 because we've moved our graph down 1. And then b is going to be +2 because we've moved it to the left 2. Okay, so we already can say that. So then if we've got our basic function here, we going to have x plus 2 minus 1. Then what we want to do is we can find an x and y point so that our only variable left is k, right? When we're solving for a variable, we only want there to be one variable. Okay, so let's say we pick this point, which is minus 1, minus 4. So our y is minus 4. We don't have anything for k yet. X is minus 1, and then we've got our plus 2 and our minus 1. So we've got minus 4 is equal to k times by minus 1 plus 2 is 1, minus 1. Then if we add this one across, we're going to get plus, I don't need to write plus, minus 3 equals k. So then we know that our k is minus 3. What we need to do is sub that back into this equation. Actually, no, we don't. We don't even need to sub that back into the equation. We can just say that k is equal to minus 3, b is equal to plus 2, and c is equal to minus 1. Okay, because all it's asking is to find the values of k, b, and c. Okay, fairly simple question if you know what to do. But yeah, that's that for functions. Oh, again, I left the slide to do it. Anyway, this is a bit of a trickier question, but it is a multiple choice. So this is question 9. So like I was saying before, as you move down your numbers in the multiple choice, they do get harder. So we've got, let h of x equal f of g of x, where the function of f of x is an odd function and the function g of x is an even function. The tangent to y equals hx at x equals k, where k is greater than 0, has the equation y equals mx plus c. What is the equation of the tangent to y equals hx at x equals negative k? Now this is quite hard because it's just a whole bunch of letters. They've not given you a single numerical value. Okay, so we first think about, so since our tangent at x equals k has to intersect y equals h of x, so they have to intersect because, I mean, it's the tangent, is going to be, so they intersect, so then our y, our h of x is going to have the general equation mk plus c. Okay, because x equals k, we can put that in because that's where our tangent is going to exist. Okay, so then if we've got h of negative k, that's going to equal f of g of negative k. Okay, if we're looking at this, if we can sub in negative k, which is what they've given us here, as our two x values that they've given up here, then we can say our h of k is going to equal f g of k, right? Because g of x is an even function. So this and this, whoops, should have done a bigger line, will be equal to one another. Because if it's an even function, this won't impact our graph. Okay? So then we can say that that is going to equal to mk plus c, because it's going to be this little bit that we've already found up the top here. Okay, and so then what we want to do is use our formula, y minus y1 equals mx minus x1, to find the actual equation. Okay, this is quite a hard question, so I'm trying to go through this kind of slower. Okay, so I want everybody to think about how they would use this formula. Okay, I'm just going to give you like a little bit to think about that. Okay, so we've just said that this is our y value. Okay, so we're then going to do y minus y1. And that's going to equal m minus multiplied by x minus, oops, I just move this down a line, equals m x minus our x1, which is negative k, so we're actually going to get positive k. Okay. So we've now got this, right? But this m value here is actually going to be negative, right? Okay, so I'm just going to give everybody a second to soak that in. Okay, and then what we want to do is then, if we multiply all of this out, y minus mk minus c is equal to minus mx minus k. Then we just want to rearrange all of this so that we get y by itself. So then we're gonna get, oops, sorry, that was meant to be mk there. I was wondering why this wasn't gonna work. Minus mk. Then we'll get y equals, if we add that across, it'll cancel that out, negative mx plus c, which gives us our answer of B. Okay, so this is a pretty tricky question. So it does take a lot of thinking, especially for it being a 1-mark multiple choice question. But it was in the 2021 HSC paper, so we've got to get everyone ready for these sorts of questions. Okay, so I'm just going to leave this here for a second, just for everybody to soak in. Okay. Okay, and so we just got to remember the tricky part is remembering that this is going to be negative. We've got to have a negative gradient because our f of x here, even though g of x is even, f of x is odd. Okay, so we've got to remember that to make sure we include this. Okay, well, that actually concludes the questions we're going to be looking at today. So now it's a little bit more just about some like trial specific study tips and just like some general tips for studying in maths in general. Okay, so I'll be honest with you guys for a second. You are never, ever, ever going to feel like you are ready to sit your trial. You'll always feel like you don't have enough time, that you still need to do more practice, that, you know, it's going to be too hard. And that's fine, you know, that's the point of your trial. So it's super important. Just try not to panic about it. I know that's a lot easier said than done. But just remember that that is the point of trials, is to be a little bit like a check-in point, so that you can see where you are really good at some questions, where there are other questions that need a little bit more work. And it's super important to remember that they are very specifically designed to be much earlier than your HSC, so that you've got a lot of time in between your trial and your HSC to refine your skills, and to practice those questions that you get wrong, and to work on the topics that you aren't so strong at. So yeah, try not to stress too much about that time element, about just feeling like you're running out of time. Although I will say what comes with that is that with trials, it is commonly for a lot of people the worst mark that you will ever get on a maths exam. And that's completely normal. And again, easier said than done, but try not to get disheartened by the fact when you get that trial back that that might be the case. Your first 3-hour maths exam, for most schools, the first time you do a 3-hour maths exam is trials, is going to be really different than any of the other exams that you've ever sat and that you're used to, because your brain just isn't used to working that hard. Your brain's going to get tired, you're going to get tired. For a lot of people, you're going to get bored just thinking about nothing but maths for 3 hours. And it's going to feel like that exam is dragging on forever. And it's just going to feel like it's never ending and like you've never done anything so long in your life. But it's okay. Sitting 3-hour papers is a lot to get used to. Especially getting used to not being able to get up, not being able to just like walk around, take a break. And knowing that you do need to be doing maths for 3 hours, right? It's not like you've got an infinite amount of time to work through that paper. It is limited. But then again, your trials are just that. They are trials. A trial of how you go sitting a 3-hour paper, how you go splitting up your time in a 3-hour paper. Like all those sorts of different things, different bits and pieces. A trial of how good you are at moving on when a question takes too long. So it's okay, no matter what mark you get in the end, as long as you can continue to learn from that and not let that dictate your motivation going forward, right? And your trials are just a big chance to see how your study's going, to understand where you need to keep working, to understand where you actually probably don't need to look at too many more practice questions on that particular topic because you've got them down pat. To look at, it's always the really wordy questions that I get wrong, or the questions where you have to do, like, make an assumption. So it's just a big chance to check in with how you're going. I'm not going to say that they don't matter, because they do. Your trials for most schools makes up a lot of your weighting for your internal rank. So it is important to study and to get ready for them. But it's okay not to feel like it's your best performance, because nobody in your cohort is going to think that your trials is your best performance. Okay? So don't stress too much about that. Like I promise, it is all going to be absolutely fine. And then I guess just look at some study tips for maths. You're going to hear this from literally every single person who's telling you to study for maths, is to focus on your weak areas. There will be a lot of areas of maths that you do feel pretty confident in, and that you don't need to look at again. And as comforting as it might be to look at those areas that you know you're doing well in, it is so much more important to focus on the areas that you commonly get wrong, right? Because with the areas you're good at, you're probably going to get those marks in the exam anyway, but you're not going to get the marks of the exam, of the questions that you're not so great at, unless you work to get better at them and to start to understand those questions, right? So if you want to maximize your marks, you want all of your topics in maths to sort of sit at the same level of confidence. Hopefully that's a lot of confidence, but anyway. So with maths, especially now that you're sort of at the pointy end, like the only things you have left are your trials and your HSC exam, super important to practice sitting a full 100-mark exam in timed conditions. If you can, maybe like sit down with like some friends or like some of your classmates and do the 3-hour exam together, just so you're less likely to get halfway through it and be like, oh, it's fine, whatever, I'll finish this later. If you're with other people, you're more likely to actually sit down and try and do it. So yeah, practice sitting them. I would say if you can at least try and do one full 100-mark paper before your trials, you'll be setting yourself up in a really good spot to at least just understand like how you go with the 100 marks, how you go getting it all done, whether you're the kind of person who, when you look at a question, you I guess if it's too hard, you either skip it and forget that it exists, or all of a sudden you're spending like 40 minutes on one question. Okay, so it's super important to see how you go. And just, yeah, especially with timing, looking at how long you want to be spending on each question. So you also want to be doing a little bit of maths most days of the week. If you can try and do at least one question from a HSC paper or a trial paper every day, you'll be setting yourself up in a really good spot, just getting so much exposure to questions. With that, I would say it's important to practice your multiple choice as well. I think a lot of people assume that if they can do the short answer questions, they'll be able to do the multiple choice, which in some cases, yeah, that is true, but it's also super important just to get used to doing maths multiple choice questions, which are a little bit different to your other subjects because they're giving you numbers and formulas and things as your answers. And yeah, they're a little bit harder to, I guess, like guess or like do like educated guesses on because, you know, it could be any of the numbers or any of the formulas or things like that. So try and do at least some targeted revision on your short answer questions, but also at least some on your multiple choice as well. But in saying that, do schedule in rest days. Don't study every single day. Don't burn yourself out before the HSC's even begun. Enjoy your 12, especially after your trials. The period between the end of trials and like graduation is such a fun time for most schools to being year 12 students. Like all your internal assessments are done, so your classes are heaps of fun. And it's just like, I guess the last time you get to like hang out with your friends and stuff all day, every day at school. So do make time to schedule in rest days and just enjoy everything that comes with being in year 12. Enjoy all your lasts, your graduation, things like that. Like you don't need to be studying every single day, especially not between trials and the HSC, or at least trials and the end of grad. So yeah, just enjoy year 12. I guess the next bit sort of lends itself to the first little topic that we talked about, but make sure you practice every single topic. Yeah, like you'll get questions from each of your topics that we've looked at today. Like there's not going to be one topic that they just like don't ask any questions on. So you do need to be familiar with questions from each of those topics. And then finally, just do as many practice exams and practice questions as you possibly can. Super important. I think a lot of people make the mistake of like not looking at like other schools' trial papers or like, you know, like the company trial papers if you can before your trials. Especially because you'll find with a lot of trials, they're a lot harder than the actual HSC exams. So yeah, if you can get trial papers from like your friends' schools, if like your teachers have like a stock of trial papers, past students will have heaps of them. So just try and do as many trial papers as you can, or at least as many like questions from those papers as you can before you sit those exams. With your trials, I would say a lot of schools wouldn't have finished the course yet. So make sure you know what you're going to be assessed on in your trial exam, because if your school hasn't done a particular topic, there is no point revising that topic because it's not going to come up. But yeah, so just be super familiar with that. And yeah, I can't stress enough, just do as many practice questions as you possibly can. And yeah, so I'll just quickly run you guys through this before the end. But if you want a little bit more help with some of the content itself, you can just look through the rest of this presentation, this slideshow. It's just got all different little bits and pieces this is all on calculus, but if you eventually keep going, graphing, if you want a little bit more help with how do you graph something, translations, dilations, sketching steps, how you approach questions, looking at arithmetic sequences and series, all those sorts of things. If you want a little bit more help actually looking at the contents, like balance loans, which I know a lot of people struggle with, compound interest as well. So yeah, if you guys want a little bit more help with the content, feel free to check the rest of these slides out, or look at some of the past lectures that have happened in the year, as well as if you do feel like you want a little bit more revision with year 11 content, do check out the year 11 lectures as well. other than that, that is just about it for today. So thank you guys all for coming. I hope you all learned a lot, and hopefully we'll see some of you again in the future doing stuff with HR notes. But otherwise, I wish you all the best of luck for your trial exams and your HSC. Try not to stress too much and just enjoy your Year 12 experience. But yeah, just looking at question types will get you the most prepared for your maths exams as you possibly can be. So yeah, thank you guys all for joining us today, and hope you have I hope you have a great rest of your day.